The average atomic mass. An element can exist in a number of forms. Like we said, we call those isotopes. And because isotopes are forms of the same atom, they vary in mass. So, for example, there are two different types of isotopes of copper atoms. One type weighs in at 62.93 AMU, remember atomic mass units, so we round that to 63. The other, copper 65, has a mass of 64.94 atomic mass units. So that's why we call those copper 65, copper 63, because that would be the average mass unit for each one of those. The lighter isotope is more common with 69.09% of the naturally occurring copper that we have, and have that atomic mass per atom of 62.93. The remainder of those atoms, or roughly 30.91% of the copper that we have, has a mass of 64.94 atomic mass units. So to find the average atomic mass of an atom, we take into account all of the isotopes that exist and the percentage of each type. The calculation of the average atomic mass is a weighted average. And so average atomic mass equation is written there in the bottom for you. So we use the sigma symbol, the mass of the isotope times the relative abundance. The average atomic mass, the bottom line is that to find the average atomic mass of copper, we insert the information about those copper isotopes into the formula I just showed you. There are two of them, so we'll be adding the contributions of two isotopes, and that's where the sigma sign comes in. The relative abundance is simply the percentage of each isotope, but in decimal form. So we knew we had 60.90% corresponds to a relative abundance of 0.6090. And so again, let's go back and look at our copper. One type of copper atom weighs in at 62.93 AMUs. The other had a mass of 64.94 AMU. So the lighter isotope is more common with 69.09% of the naturally occurring copper, which we said has the mass of 62.93 AMU per atom, and the remainder, which is 30.91%, have a mass of 64.94 atomic mass units per atom. So our average atomic mass of copper equals 62.93 AMU times the relative abundance, which we said was 0.6909, and then we're adding that to the multiplication of 64.94 AMU per atom of the copper 65 times its relative abundance of 0.3091, which equals an atomic mass unit per atom average of 63.55. This would be what you would see on the element itself. And so from this calculation, we know that the average atom of copper, we just found one piece of copper that we would know that a pretty good average mass for it would be 63.55 AMU. Notice that in the problem, we would predict the average to be closer to the weight of the lighter isotope. This is because the lighter form is more abundant. So let's practice. And we're going to use silver. And so we have silver 107 and silver 109. And we have an isotope mass for silver 107 of 106.90509. For silver 109, 108.90470. And so we know that isotope percentage for silver 107 is 51.86%, which would leave us with 48.14% for silver 109. And that's our first question. What was the percentage for silver 109? So we figured that out by taking 100 and subtracting 51.86. So now we have to find the average atomic mass for an atom of silver, or Ag, as it's abbreviated, the element symbol. So there's our equation. We take silver 107. We take its average atomic mass unit per atom of 106.90509, multiply it by its relative abundance of 0.5186, and then we add that to silver 109. We take its average mass unit of 108.90470, and that should be a multiply, times its relative abundance, 0.4814, which gives us the average atomic mass of 107.88. Okay, so that's the end of our introduction to the atomic theory. And make sure you get your notes copied on the note sheet, and you filled in the blanks as we go. If you have any questions, feel free to comment on the YouTube channel so that one of us on the chemistry teaching team can answer your questions, or be sure and write it down for class.